Right now. Okay, we are starting up. Let's make sure everything is up and running. So I often do because, I never trust myself completely. Yeah, looks like everything's good. Beautiful. All right, guys, we have a lot to talk about tonight, so let's dive right into it. First of all, uh, I'm going everything that we make in the the merchandising shop. Um, I'm going to buy. So this is our tumbler with a lot of coffee, and it's cool to the touch, but
Coffee's piping hot.
oh yeah, nice and hot. And what is it again? It's caramel coffee, right?
Vanilla or something. I told you
Ooh,
it's hot.
yeah. Wow, nice. Alrighty then. Well, that was a nice jolt of caffeine. Okay, so we have a lot to talk about here because I'm seeing a lot of things going on in the atmosphere. We're going to talk about the evolution of the stratosphere, what's going on with La Nina. We're going to touch on the strong cold front and me watching the on the 850 millibar low level jet and why I'm concerned about that for Friday morning. There's also a little bit of a threat for some snow for the higher elevations, especially for the Poconos and the Catskills. But let's start off first with the overall pattern overall. And first thing I want to do is discuss our apartment. Our apartment right now is very, very warm. It is currently 81 degrees in here, okay, with my Kestrel. And the reason why I'm showing you this is that we don't have the heat on. This is due to the people below us really enjoying their heat quite a bit. And so all that heat, all that air rises up into our apartment. Now you might be wondering why am I sharing this with you? Well, that's essentially what's happening with our atmosphere, where a lot of warm air that is building up in the troposphere is rising up into the stratosphere and disrupting or setting the stage to disrupt the polar vortex, much like the warm air in here is disrupting our ability to stay comfortable. Although, Susan, I think you're doing a wonderful job already starting to decorate for Christmas and whatnot. So she is doing an outstanding job with that, putting lights around the TV and whatnot. So when you think about that, when you think about air rising, that is why we're going to start off with what is happening here. This is, if I can zoom in properly, this is 10 millibars. Now remember last week when I said, watch out for this area right here for evolution of a major warming event. And let's look at what's been happening since October, late October, early November, boom, there it is. So the question is, what's causing that at 10 millibars? Well, the best way to describe it is called the EPV flux. Okay, now this means that air is moving from 30 millibars to 10 millibars. And where's that air warming coming from? It's warming from the troposphere around the tropics into the stratosphere towards around 90 north, 80 north. So the air is rotating upwards. So all the warmth that we're seeing down here around the tropics is getting transported and helping to disrupt the polar vortex. And the more that you see this signature showing up, these arrows, these vectors pointing upward like this, the better chance you have of transporting heat from the troposphere to the stratosphere. And so that is how you end up with this signal and the observations. We're not talking about models just yet. We're just talking about observations in the atmosphere. And so that's how you start setting up this environment, where at 50 millibars, and this is the European guidance, you start to get this warping. Now, it isn't completely weak, and it certainly isn't nowhere near split, but this warping, at the very least, starts to establish the potential for a sustained negative EPO pattern, and at the very least, a trough over the central and eastern parts of the United States. And you're seeing this same theme showing up on the GFS guidance. So the GFS ensemble guidance will do 12Z here, just that way we can keep the same hours in sync here. 240 hours, you see that warping. Now, in this case, it's trying to split it. I think the GFS might be a little bit too aggressive there. But you can see the overall theme here, in which you get this kind of stretching going on. And when you start to see more of a spread towards North America, that means that the model guidance overall is leaning towards this shifting towards North America. When we take a look at the temperature anomalies being forecasted for this, again, we'll stay with 12Z here. You can see that evolution taking place here. So what's actually happening here? Well, you're getting your warm air. In fact, hold it. Let me pull up winds here. There we are. We'll do 50 winds at 50 millibars on the GFS. I'm going to use the GFS a little bit more just to show you this isn't just a European model guidance thing. This is also showing up on the GFS as well, where you're seeing this warping taking place, right? But what's key is to understand that the air mass here is getting drawn up, wrapped around, and then finally reaches 10 millibars right around Asia, matching up exactly to the observations that we're seeing here. Notice in our observations, we're seeing a lot of warmth here. Now, why is all of this important? Because of the nature of the lifting in the atmosphere. I have been beating the drum for some time that this La Nina that some have been advertising and have weighed heavily on with the seasonal forecast is, well, less than impressive. Don't take my word for it. Take a look at the observations. We'll start at Niño 4, which is right about here, right around the date line. And very marginal. Minus 0.5 degrees Celsius below normal. 3.4, which everyone usually looks for in terms of the anomalies, is minus 0.7. So again, that's weak. And again, we are in November 10th. At this point, this La Nina should be rocking and rolling and strengthening. And if it's going to become a moderate or strong La Nina, it would start kicking, right? Minus 0.6. All these are in weak anomalies. Finally, we get to Niño 1 plus 2, minus 1, essentially. You want to round it up to minus 1.1? Okay. So you have your coldest anomalies in the far eastern zones. Sound familiar? Okay. Well, there's also another way to look at La Niñas, and I explain this every day, pretty much with the premium members, is that understanding the SOI. Now, the SOI is really important because it's the measure of how the atmosphere is responding to La Nina. You can look at cold temperatures all you want, and look, it's really good to understand the process, to understand the gradient. But to get a real good idea of how it's influencing the atmosphere, you really want to take a look at the SOI to get the idea of what the pressure difference is. The stronger the pressure difference, the stronger your winds are, and also the deeper the convection, the more influence it has on convection. typically you want to be around 8 in your SOI for La Nina, for it to be considered at the very threshold of La Nina. Okay, your strong La Ninas are like around 25, 30. Your moderate La Ninas are typically in the teens to lower 20s. Your weak La Ninas are in your 8, 9, 10. And that is essentially what we've been dealing with. In fact, the 30-day average was even below 8, which was a bit surprising. I didn't think it'd get this weak, especially in November. So clearly we are seeing all these indications suggesting a weak La Nina here. And this is not like some model, pick a model, CFS, GFS, ABC, 1, 2, 3, UK Met, whatever. It doesn't matter, okay? These are observations, and observations are always king. The reason why is because they're observations. It's not an assumption. It's not a model error. It's not a calculation. These are the observations. It is what it is. As Coach Parcells would say, you are what your record is. You are what your observations are, okay? So this is what we're dealing with here. This is the environment that we're dealing with here. So if we have a weak La Nina, and the MJO is basically, well, MIA. I mean, it's in a neutral state. It's expected to move towards phase 7 right around early December, which should make things rather interesting. Because remember, MJO, when the MJO is in phases 7, 8, 1, and 2, we are expecting an active winter weather pattern for the eastern United States, and that's exactly where it's moving towards. Now, another way to take a look at this is to look at the convection. And let's see here, where's that observation? I know it's right here somewhere. Here we are. Let me enlarge this. Now, what we're looking for when the pattern gets active by us is that you want to go to the date line and then take a look at the convection right here. Okay? The stronger this is, and we know this by Coast and Utilities work, okay, especially from the Northeast Storms book. Let's see here, Northeast Snowstorms. Okay, check it out from the AMS. An outstanding book, an outstanding research. We know that when we see convection festering around the date line, that's typically when we see our most active winter weather patterns. In every active winter weather pattern, it was the hallmark of those patterns was active convection around the date line. And what are we seeing now? Active convection around the date line. Where are we seeing a suppression? Basically right where the coldest waters are. And this is why it's important to to determine what type of La Nina you're dealing with. West-based, east-based. Okay, because it matters. If it was a west-based La Nina, which means your coldest anomalies are towards the date line, all this convection gets shut down and everything's focused around Indonesia. When you have an east-based La Nina, you allow the convection to expand because your thermal gradient has shifted off towards the east, and so that's how you end up with this feature. Now again, this is all happening with a neutral MJO pattern, which means you're neutral in terms of other forcing parameters. So when this goes into phase 7 and 8, that enhances the pattern and leads to more amplification because all this convection starts to interact with these short waves here in the polar jet stream. And that's how you get strong upper level lows. So what I'm doing here is I'm laying the groundwork of the overall forcing mechanisms in our pattern. So that way you're prepared as our pattern shifts and amplification starts to take hold again. What are the lifting parameters that are going to drive that amplification and how the pattern shapes? So I would not be surprised if you start to see in the model guidance as it takes in all these observations that 10 to 15 days out, you start to see more and more signals for amplification and for high latitude blocking. Yeah, that's good stuff. Okay, so we got that overview. Then we have our pattern overall. And when we take a look at the water vapor satellite picture, yep, we got a nice little upper level low here. We have a nice convection starting to form here with our cold front. Let's see if we can zoom out here. Refresh weather tap here. Continue. And pulling in some new data. I could have swore I did this beforehand, but that's okay. We will add a front and we will zoom out. Yeah. And zoomed out too much. There we go. Okay, so clearly we have plenty of convection and heavy rainfall forming out here over the upper Midwest. What is driving this parameter? Well, let's zoom out and we'll go to full sector and we'll go to 850 millibar winds. Take off the radar and voila, there is our nice low-level jet at 850 millibars, right around a broad area of low pressure at 850 millibars. This is going to set up a very interesting pattern for us as we get towards Friday morning. And I've been talking about this quite a bit with premium members, and I'm warning you right now, I'm a little concerned about Friday morning. And I'll show you why with new 18Z guidance that just came in from the European guidance. This is why I love the clocks falling back, so I can pull up the latest model data. Take a look at this at 7 a.m. Those are some strong mid-level winds at 850 millibars. And we have very heavy rainfall marching its way through. Some of these winds are going to get mixed down. You're going to be talking about wind gusts somewhere between 30 and 50 miles per hour. I would not be surprised if we get a wind advisory out of this. So if you have plans, obviously most people have plans traveling on Friday morning because, you got to go to work. I would use some caution, give yourself some extra time. As this wall of heavy rain comes in, you're going to have a strong moisture transport coming in from the Atlantic. You're going to have plenty of mixing involved. And I would not be surprised, even over the Poconos and Catskills, you're going to get some mixing down. And it's going to be a rough evening, or should I say morning rush hour. And when we take a look at the hour-by-hour analysis here, and we'll also take a look at the NAM at this as well, you're seeing this march of heavy rainfall coming in. This is from the 12Z guidance. See how the 18Z guidance not in yet. Let's see how the NAM looks on this. And the 12Z. And this right here, this signature right here, is the moisture transport coming in Friday night with the southeasterly wind. And then there is our southerly wind with the low-level jet. There's some heavy rain associated with that on Friday morning. And the 18Z guidance is essentially showing the same thing. So the overall theme is that Friday morning looks rather rough. Then there's a question about the potential for snow for this upcoming weekend and into Monday morning. When I say snow, I mean the highest elevations and not a lot of accumulation. But it should be interesting nonetheless because of what we're seeing here with 850 millibar temperatures. If I can pull that up. Right here. And again, we'll do 12Z. And you see this ball of cold air coming in. Saturday is still going to be a relatively warm day, but Saturday afternoon, you're going to see that cold air really start to push in, temperatures start to free fall. And then on Sunday and Monday, you got these short waves coming in. And there's actually pretty good agreement between the GFS and the European guidance on the strength of these short waves. And we'll do relative vorticity, which means the vorticity is on the same plane. And you could see First the cold front, then one short wave comes through, and then the next short wave comes through. So you have the cold air coming in, you have PVA rotating in. I think most locations will just have, widely scattered showers on Saturday, Sunday, and Monday. But Sunday and Monday, I think what you'll experience is that even along the coastal plain, do not be surprised to get some rain mixed in with some sleet and snow. No accumulation because the boundary layer temperatures are going to be way too warm. But just don't be surprised by that. And also, don't be surprised for your highest elevations, let's say above 1,000 feet in the Poconos, Catskills, to seeing a little bit of light snow maybe on your cold surfaces, okay, with some of these snow showers. Now, what's interesting is that with this type of cold air transport coming into the Great Lakes, let's see if we can look at the new 18Z guidance. This type of cold air coming into the Great Lakes like this, again, we'll use the 12Z as well. That's going to lead to some lake enhancement and lake effect snow. Do not be surprised if there's a snow squall coming out of the Great Lakes on, let's say, a Monday morning around the Poconos, Catskills, maybe drops a quick inch for your highest elevations. I could certainly see that being a case. So a lot of interesting stuff evolving here with our pattern. No major storms just yet. I think that your best potential for major storms, unfortunately, is going to be starting to set up around Thanksgiving, right around that last week of November into early December. But at least for now, nothing major is on the horizon. But plenty of a shift from our mild pattern with the zonal jet to more of an amplified jet. So now with that, let me go knock off a couple of questions here and see where we're at. And then we'll go with that. Okay. So let's see here. Yes, the tumbler is for hot and cold drinks. The idea is that whatever you have in here is going to keep it that way. So the coffee is certainly hot. And if I put a cold beverage in here, it would remain cold. It's really awesome. No, it's not hot to the touch. Like holding it, it's fine. But inside, yeah, it keeps whether it's cold or hot, it keeps it that way. Cars asking, if they keep their heat like that, it will certainly help with your heating bill, although the temperature is way, way too hot for me. Yeah, that is definitely the case. I don't think we're going to be needing to turn on the heat all that much if we keep this up.
Flashbacks to decorating for Christmas in Florida.
What? Yeah, that's pretty warm. Yeah, so there we go. We're gonna have to put on the humidifier even more so because dry heat's not good for you. Took your advice and already hung up all the Christmas lights. Got a feeling from the 19th on till Christmas is going to be a roller coaster of storms. Yeah, we're already working on the Christmas stuff right now. We typically don't, but I kind of have a bad feeling that I'm going to be pretty busy, and I want to help out a little bit, or at least sound supportive. So, so yeah, we're starting now. Got a thing. Let's see here. Okay, getting a question about the Eastern Great Lakes with snow potential. This is a great segue. Let me segue into this. Let me see if I can zoom in to, let's see, Western Atlantic. No, okay, Northern Atlantic. Okay, let me try pulling up Great Lake sea surface temperatures. I probably should have pulled this up beforehand, but anomalies. Okay, so here's our latest sea surface temperatures for the Great Lakes. And this is actually well above normal. Now, the reason why I'm pointing this out is that the warmer that the Great Lake waters are in the fall, the higher potential, if you get some really, even a marginal polar air mass, to really produce quite a bit of snowfall. The last time I saw something like this, it kind of reminds me of back when I was a sophomore in Oswego, New York, which is right about here. Okay. And I went to this college specifically because of the lake effect snow. I went to Penn State. I could have gone to Penn State, could have gone to Rutgers, could have gone to Linden State, Texas A&M, all sorts of colleges, right? Um, and then I went to SUNY Oswego. And me being a snow lover, of course, I go there right when there's a lake effect snow ban. And I'm like, I'm done. I know where I'm going. That's it. So my second, not my first Thanksgiving, my second Thanksgiving coming back, the lakes were very warm. The water temperatures were very warm because we had a warm fall, and then we had a polar air mass came in. Temperatures only got down to in the upper 20s to lower 30s, which isn't all that impressive for that area. And boy, did we get walloped with like 25 inches of snow coming off of the lakes via one band. And it's kind of the same type of environment taking shape. So I'd be very, very cautious and keep an eye out on lake effect snow towards the end of this month. And also, if you're in the Poconos or Catskills, I'd keep an eye on those bands, especially get a good northwesterly fetch from 500 millibars down to the surface. Oh boy, those could definitely be a nice surprise. Is the wind concern mostly straight line winds or any potential for rotation? For Friday, it's mostly just straight line wind potential. I'm not really looking at this as more of convective, and I've been keeping an eye on the SPC, taking a look at the overall evolution. I'm not seeing severe thunderstorms at this time, but I'm definitely seeing some straight line winds get mixed down from the heavy downpours. We have another question from YouTube. Oh boy. We got quite a few times. All right, so I'm going to bounce back and forth and kind of weed out the best question out of YouTube here. Let's see here. That's the main idea. Weaker La Nina, so snowy winter becomes more likely. Okay. When it comes to snowier winters or not snowier winters, when it comes to La Nina, the key thing is again to understand what the driver is. If the driving mechanisms here was that the polar vortex was not really much of a factor, and it was already weak, and the primary forcing mechanism was more of the tropics, then the state of La Nina would be far more important. The point I'm trying to make is that the most important lifting parameter here going into the winter is what's happening with the polar vortex and not necessarily what's happening with La Nina. I think that if the polar vortex remains strong, which right now I don't think it will, but let's say it does, that's going to lead to a mild winter, regardless of what La Nina does, whether it weakens or what, okay? But if the polar vortex does get disrupted and you see stretching and splitting into two and whatnot, then game on. And it's going to get very interesting from the Rockies on east then. Let's see. I can understand the equilibrium of the east and west La Nina temps. Can you give a little explanation of how it translates to more of an active pattern here? It all comes down to convection, okay? When it comes to tropical forcing, whether it's El Nino or La Nina, it comes down to two factors. One, the strength of the event and the orientation. And the reason why is because that dictates the convection. Okay? If you have a strong La Nina that is east-based, and you have a lot of convection going on around the date line, that can still lead to a very interesting weather pattern. thing is that strong La Ninas typically overwhelm any influence of the polar vortex, and you still get a sizable ridge over the southeast. So, you snow lovers don't want that. You snow lovers, you do not want strong El Nino or La Nina events. You can end up with a pretty good winter, but it's far more difficult. I mean, everything has to fall into place perfectly. If it doesn't, it's just mild, right? What you want are weak events. That way that the polar jet stream could do its job and transport cold air to the mid latitudes. And so the key factor here to make this simple is to find out where your convection is in the tropics. The closer it is to the date line, the better potential it has to influence troughs around the Aleutians. You get a below normal heights to the south of the Aleutians. It's called a negative EPO pattern that supports a ridge over the western United States, trough over the eastern United States, and supports a higher potential for a negative NAO pattern, which you guys all know about, which leads to increased potential for storms. Everything's connected. What's happening in Indonesia, what happens around the date line, has a direct impact on what could happen on the East Coast. And all of that plays into where the orientation of an El Nino or La Nina event is. Okay, back to the premium section here. Let's see. At 10 millibar level, it looks like there is a healthy stream of air going from the tropical regions to the polar regions. You can see it on Earth.NewSchool. Well, let's check it out. Let's see. You said 10 millibars. All right. And we'll do HD. And let's zoom this out. Okay, that's a little bit too zoomed. Whee! All right, there we are. Okay. So, let's see what we got here, right, guys? And we're going to go to the tropical Pacific and look at our winds. They're coming in. There's Australia. There's Hawaii. There's our date line. Here's our winds coming in. And let's follow this area right here. And let's see where this takes it. Here's our air transporting in. It's rotating around, cutting across the Pacific, transporting up, and wrapping right around. So where is this air coming from? Where did I say? Tropics, right up towards the polar regions. And if we take that and convert that to temperature, you can see how that heat transport is taking place. So some very interesting stuff. Good job, card. Snow in the air for the weekend football games. Nothing that's too significant. Maybe flurries. I mean, I'm not sure. Is there any? I'm not good with college football games, but I'm pretty sure there's nothing at the top of the Poconos. Like they're not playing on top of the mountains, right? Right? I don't think so. No. That'd be cool. Putting a football stadium right on top of a mountain, you'd be guaranteed to have some snowfall games with that. But no, I mean you're gonna have to be way up in the elevation. That would be fun. I would actually have fun with that, but no. Does the tumbler have a lid? It sure does. Yep, it does. I don't know if you could see it, but there it is.
Slides too.
And it slides. It's very good. Is there a time frame you have in mind for our first significant snowfall threat? Depends where you're at. If you're in the interior, I would not be surprised if we see something between November 25th and December 5th. I would not be surprised by that. So I'm going to start looking for that time period to start off with the interior, talking about the Poconos, Catskills, whatnot. For the coastal plain, remember we have very warm waters along the East Coast, which means that our boundary layer is going to start off warmer, which means that in order to get a significant snowfall, we're going to really need an intense storm to rapidly cool the boundary layer. So I'd want to wait after December 15th if there is going to be anything. And I'm talking about Philadelphia, the Hudson River Valley, New York City, Delaware River Valley, those areas. Unless you're in the highest elevations, I don't see us getting into the snow game, so to speak, until after December 15th, unless we get something really impressive. And the reason why I say that is because by December 15th, we should be able to cool the waters enough to not overcome the boundary layer influences if you get a northeast wind. Hudson Bay is really above normal. What impact, if any? It's actually going to help to enhance the build of snowpack by next 7 days with all this cold air coming in. So you're going to get, I guess you could call it Bay effect snow in Canada. Won't have any direct impact on us, though. Now, Hudson Bay usually cools down pretty good once it gets rolling in December. The water off the northwest coast looks like it really went way below normal in temperatures. Ah, yes. Let me pull that up. World, please. Boom. Well, as I've been saying, we have a real textbook negative PDO. And I said this all the way back in the summer, so that this is going to be a very impressive negative PDO event, and that's essentially what we have here. With that being the case, this doesn't surprise me. This all comes into the drought situation in the West. You might have heard about the major drought that's starting to take place or is in place in California, the desert Southwest, whatnot. This isn't new. It's not a climate change situation. It's part of the climate, okay? And that's driven, and we actually have data going back via the tree bark, going back to, I think, around 200 AD, I think, where it shows that when we had a situation for a negative PDO, that led to a sustained drought over the West, with a ridge dominating over the desert Southwest. At the same time, this signal, combined with weak La Nina or El Nino events, led to a very active and wet pattern over the eastern United States. Combine that with a negative AMO pattern, which is what we have here, and you end up with a very interesting pattern repeating itself. So, if you want to blame the mega drought, that is why we're having the mega drought in the West, and why things are going to get pretty interesting in the East, in my opinion. Let's see. Another question here. A cold snap beforehand to cool off while the concrete pavement would be helpful. Absolutely, yeah. Jumping back to YouTube. See, wow, we have a lot of questions. Let's see what we got here. Pick the best one. You forecast with any certainty weeks from now. Well, I mean, it depends what you're asking. Okay, if you're asking for, like, is it going to be a certain temperature in my backyard 2 weeks from now? No, I can't do that. No one can do that. Let's see. What do you expect? When do you expect Clipper type storms to start? We're already starting to see the evolution of some Clipper type storms already starting to show up. The low pressure system that moves through on Monday is a good example of a Clipper type system. And let me pull up the 500 millibar PVA to show you exactly what I mean by that. Let's see here. Where are you? Oh, there you are. Okay. So, when you see, there's our upper level low. Now you see this signal right here, and then the next one that follows behind it. Those are Clipper-like systems. Beforehand, they were just kind of getting crushed, okay, and not really able to form the past couple of years. And so the Clipper has been almost pretty much MIA. But we're already starting to see a signal of those Clipper-like systems showing up in the weather pattern. Now, they're not going to pack the same punch as they would in the middle of the winter because the polar air masses haven't been established yet. But they're moving in that direction, and you need these type of short waves to start to establish the transport of more snowfall towards the northern plains, which allows for a snowpack to sustain the cold air masses so you don't get moderation. And each clipper that moves through as we move forward over the next couple of weeks will instigate more and more of those changes. Let's see here. Great, thanks. What effect will rapid snow cover in Canada have on December forecast? Well, it's kind of already built in terms of my expectation. Here's the thing, okay? And let me pull this up right here. You see this right here, this anomaly? That is not good, okay? If you are a snow lover, you do not want to see this because this means you got a lot of barren land here. And so when cold air masses come in, they're going to be able to moderate pretty quickly. Now, what's interesting, what could potentially be a game changer, is that we are expecting to see a pretty good expansion of the snowpack. And let me zoom in for United States here. And so, again, below normal down here, right? Normally it should be at least some snowfall. Look what happens over the next 15 days. Now, part of this is because you have so much warm water up here in the Hudson Bay, you start to get this bay effect snowfall starting to show up here. But you see that growth? There's your lake effect snow signature, textbook, right around the Tug Hill. And so what do I take from this analysis? Well, first of all, don't ever take it verbatim. I'm not saying that, hey, I'm going to use this snow map and make a forecast for X amount of snow. What I'm saying here is that what the model guidance is seeing, and now, let's see, this is a 12Z. I've been seeing this for like 5 days running now, is that there is going to be very strong support to flip that negative anomaly, which is right here, to go from below normal to near normal. We're going to take a look at climatology 15 days from now. If we can, let me go back. By the 19th, climatologically wise, typically this is where we would expect our snowfall. Not much around the Great Lakes, most of it confined to Canada. By November 19th, that's 9 days from now. What's being forecasted would lead to above normal anomalies over the northern tier. And you need to establish this signature here in order to have polar and Arctic air masses drop south and not moderate. So if this verifies, again, this is like the 5th model run that I've seen this type of signature, and the same thing is showing up. Let's take a look at the GFS solution on this. Let's see here. Here we go. Pull this up. And I'm going to pull this. And look, same type of signature showing up. Now again, I wouldn't take any of this verbatim, and I'm sure everyone's going to focus in on this. But what I want you to understand is that there is very strong support for an expansion of snowfall, which means you see an expansion of the potential for stronger polar air masses moving forward. Let's see here. If I recall correctly, some of the western mega droughts lasted well over a century, in one case over several centuries. Yep, wiped out an entire civilization, in fact. And they weren't even playing golf. Think about that. Let's see here. The shortwave energy in the northern Midwest is a great sign for the end of the dreaded split flow jet, mainly the subtropical jet, keeping us snow lovers too warm in the past. Okay, well, there's still going to be that factor moving in. Um, the the question is interaction, right? Um, and a lot of that is going to come down to how high latitude blocking sets up. You can have a negative NAO pattern, but the orientation of that blocking pattern can lead to still a mismatch of timing. So that's not, I don't want to guarantee anything, that's what I'm trying to say. What's the most intense snow belt snow you've ever heard of? And just got a couple of years ago, around the Great Lakes, they had that blizzard around, I think, Buffalo, where they get like 75 inches. I think the Buffalo Bills had to dig out or something like that. That was pretty intense. The most intense I've ever experienced was 40 inches around Syracuse and Oswego back in 2001, I think. That was pretty crazy. But again, from someone who's living in New Jersey, dealing with a snow band dropping snow at 3 inches per hour, I was like in my glory. I couldn't believe what I was seeing. Whereas people living up there are like, oh yeah, this is a moderate band. I'm like, are you insane? This is insane. This is crazy. Then again, when I was in Oklahoma, there was a tornado passing by our neighborhood, and I was freaking out, and other people were out taking pictures of it. And I was like, it's a tornado. What are you people doing? Like, yeah, it's just going to pass us. So, again, if you're used to these type of things, if you see it all the time, it's not really that big of a deal. But if you're not, it's like, oh my God, the world's ending, and everyone else is like, nah, it's fine. It's going to miss us. Let's see here. Yeah, they had some really good ones in the 1970s. In the 1970s, the Great Lakes were very warm, too. Same type of scenario. And in the 1970s, you had a negative PDO and a negative AMO at the same time. Much like this year. I gotta wonder about that one, right? So certainly some very interesting data is showing up here. We're seeing a lot of observational data. We're seeing the transport. Essentially, and I'm not trying to toot my own horn here, but everything that I mentioned in the winter forecast thus far leading into the winter is starting to show up. Every factor. One of the wild cards, like I said, was a concern maybe La Nina could end up too strong. That is clearly not showing up at all. It's pretty much fallen right into place. Then there's the polar vortex. Hey, it could end up being too strong. That is not showing up. That's actually working out pretty well so far. We'll take a look at 10 millibars. You can see that disruption starting to show up. More so of 50 millibars. That disruption showing up. When you get this stretching here, it doesn't support a strong negative NAO pattern, but it starts to lay the groundwork to get this to start to split. And you're seeing a lot of focus of below normal heights. Again, this isn't temperatures, these are heights. Below normal heights focusing more towards North America than in Asia. Remember, one of the concerns I had was, hey, if this ends up in China, guess what? We're mild. But that does not appear to be happening at all. So a lot of interesting things are taking place here. Sun has 3 sunspots, but they are quite quiet and stable today. No CMEs coming. Yeah, for once, the sun has been very active. I expect it to continue to remain active. And that's kind of important because the more active the sun is, the better potential you have in breaking up ozone and cooling the stratosphere overall. So you might be thinking, hey, that would mean a stronger polar vortex. And in a vacuum, yes. But that also means that you open up the potential when you have transport coming in from the lower levels, or basically someone turns on the heat downstairs below you and heats everything up above you, to create anomalies. And that is how you end up with this scenario. Let me see if I can pull this up real fast. That's how you end up with this showing up. And let me pull up one other thing here. I want to show you this. This is how you get your ozone concentrations. I've been talking about this every week for at least 3 years, tracking this. This is how I find out whether or not we're going to be seeing high latitude blocking or not. Because you have to look at the atmosphere in a 4-dimensional parameters. And when you look at it in 4 dimensions, then you understand all the transports involved. And in this case, this right here is buildup of ozone. And look where it's building up towards. The negative EPO pattern, right around the Aleutians. Where are we seeing our upper level lows focusing? Right around the Aleutians. Everything is interacting. So it's not just one factor, the sun. It's the sun combined with the transport in the atmosphere. So you're cooling the overall plane, but you're transporting this heat up towards the stratosphere, leading to this plume. Should I collect right there? Leading to this plume. There's the first one. Here comes the second one, firing right up. Where did this warm air come from? It came from here. And it's all the transport. And we're all seeing this in the observations and how this all interacts. Now the question is, going forward, how does that disrupt the polar vortex? Does it split it? Does it stretch it? And in that case, how does that augment the high latitude blocking moving forward for December, January, and February? So, rough winter for Bering Sea fishing boats. Yeah, oh yeah, totally. Definitely. Let's see here. Although all CME sunbursts seem to be hitting the southern hemisphere or missing the Earth entirely. Yeah, for the most part. We also have more questions on YouTube. Let's see what we got here. What's that? Okay, I see. Let's see here. When do you expect bitter Arctic air to invade the eastern United States? Yeah, not sure yet. I have to see when the polar vortex gets disrupted. So I'm not sure yet. Okay? Well, my bet would probably be second half of December. But I'm not 100% sure on that. With the negative PDO established, do you expect possibly colder winters in the future? No. Let's see. How do I answer that? It depends on what other parameters are also interacting with that negative PDO pattern. And there's nothing to say that the negative PDO remains as strong as it is now, or other factors could overwhelm those influences, like an El Nino developing, or disruption in the polar vortex, or a very strong polar vortex, or something going on in the Atlantic, or in the Pacific, you get a typhoon lifting up. That's a category 4 or 3 or 4 storm that can amplify the polar jet stream. My point is that in atmospheric science is a study of chaos. It's fluid chaos. And when you start to try to lock yourself in to one parameter or the other, that is where you mess up. That's where you make your errors. Okay? So what you want to do is take a feature that is semi-stable, because nothing is ever completely stable, and look at all the other lifting parameters around it and try to determine which lifting parameter is stronger or more important than the one that you're studying. Is it the most dominant feature? Or is it a feature where it's driven by other parameters, thus leading to the nature of the PDO? Because the PDO is more of a reactive state than a controlling state. And what I mean by that is that the PDO is influenced by other factors going on in the atmosphere. It doesn't always control what's going on in the atmosphere. Okay, it's a reactive state. A lot of good questions out there tonight. Really good ones. Do you expect I got Weatherwise magazine? Not sure what that's about.
All the names, dear.
Well, I'm trying to. There's a lot of questions coming in tonight, and I also got. I haven't seen that one yet. Message retracted. Oh, how is the snow cover in Siberia? It's actually above normal. The snow cover in Siberia ended up above normal, slightly so. So not incredibly strong, but more interesting is the significant snow growth. I can pull up the right one. Let's see here. Here it is. Let me pull up the departures for this year. Oops. Okay, so the departures this year, well above normal in Eurasia. Europe is a little behind normal, but I don't care about Europe. And you're already starting to see the changes in North America starting to take shape. Okay, let's see here. Let's see. I remember. Here's a couple of questions from Card. I remember that winter polar vortex weekend. It split and set up right in Asia, and we got a straight zonal Pacific jet. Yes, that winter. Well, what was it? 2016. Everyone, including myself, was all looking for that winter to be just insanely busy. Okay, all the factors looked like it lined up, and then the polar vortex dropped into China, and that was all she wrote. That was it. It was done, and it was a mild winter after that. That was something. And meanwhile, like China got bombed. They had like the worst winter they've ever seen. Tropical Pacific ended up rather quiet for the basin, didn't it? Especially the Western Pacific. Yeah, it's been unusually quiet, especially for a La Nina. Usually La Ninas see a very active Western Pacific. Did not see that this year. So that was something that was a bit of a surprise. I was kind of expecting more typhoons to lift up into the Northern Pacific, but nothing really fired up. At least not to what you would normally expect. I mean, normally the Pacific is active in the first place, but really nothing that was out of the ordinary. Oh, wow, it's already almost 9 o'clock. Well, there we go. We've had a heck of an evening already. We answered a lot of questions, and we had a lot covered. You guys did a great job answering questions. Just to wrap things up, beware of Friday morning, okay? Because Friday morning, I think it's going to be very stormy, okay? And I think that the travel conditions are not going to be all that good. And then this weekend will be unsettled. Saturday will be relatively mild in the 50s. Then Sunday, the bomb drops out, and that's when I think we could see some rain-snow mix even push down towards the coastal plain. No accumulation, but don't be surprised if you see a snowflake flying around and floating about, even on the coastal plain. So that's it for tonight. We will be back next week. Thank you again for everyone traveling. The cup is outstanding. The coffee's nice and hot and warm. I will be drinking it through CSI for the rest of the night. And
I like the top.
Yeah, I like the top too. It's pretty cool. It's very nifty. And we're going to have more stuff on the way as far as merchandise that's being developed.
Testing everything out.
Yep, and the hoodie's up there too, so definitely check that out. I actually ordered one as well, so I'll be wearing that, so that'll be fun. So that's it for tonight. Have a wonderful night, and as always, stay safe out there.